All right, so to start out our perspective drawing adventures, we really need to learn about the fundamentals, about the idea of the horizon line and the center of vision and diminishment and foreshortening and all this good stuff. So let's go ahead and get started with that. Welcome to the Perspective Basics class. We're going to talk about the basics of perspective and what we need to understand in order to draw boxes and cubes using perspective. The first thing we want to understand is that since cubes and or boxes are 3D, we're still going to be using that rule that every cube or box has three sets of lines. They have height lines, they have width lines, and they have depth lines. All right, so three sets of lines, 3D. Or if you're sending a package, they'll say height, width, and length. But I like height, width, and depth. But whatever you call it, it's still only three sets of lines. So three sets of lines. In each one of those sets, we have 3 or 4 lines. So your box is either made up of 9 lines or 12 lines. And then the relationship, so the 3 or 4 lines, there's 3 or 4 lines in each set. So 3 times 3 is 9, or 3 times 4 is 12. There you go. But the relationship of the lines in each set is that each set of lines is parallel. Okay? So when we made those boxes in the Power of Line class, we would create boxes where the lines were completely parallel and none of the lines got closer to one another. We're going to find that that's going to change now that we're talking about perspective. So again, in the first class, we talked about front view boxes and corner view boxes. And the front view boxes, we could see the front face and were 90 degrees to the line of sight. And that the corner view boxes were not 90 degrees to that line of sight. So we were drawing corner view boxes and front view boxes using the method of 3 sets of 3 or 4 lines that are parallel. Now we're going to learn a little bit more about parallel lines. And not only that, but those front view boxes and corner view boxes, we're going to clarify that and we're going to give them their proper names. Now the first thing we're going to talk about in perspective is that whenever we're using perspective, we always have a horizon line. And the horizon line is very important. And it's also what we will refer to as the eye level. So the horizon line and the eye level are the same line for 1 and 2 point perspective. So whenever we have a drawing, whether we use perspective or not, there's always an eye line. If we open our eyes, there is an eye line. And so the important, or the eye level as we'll call it, I said eye line, but eye level is probably the more proper term. But again, the horizon line and the eye level are the same thing. And what that eye level is the eye level tells us how far our eyes are off the ground. So if we were sort of squatting down like this, you know, your eyes might be only something like, depending on your height, between 38 to 42 inches off the ground, depending on how low you were kneeling down or what. Or are we standing, and let's say this person is 5'5", and so his eyes are about 5 inches down. So let's say he's at a 5-foot eye line or horizon line if you're standing. And if someone was standing on a ladder, perhaps this man is 9 feet off the ground, and so he would have a different. All 3 of these people have different views. All 3 of these people have different perspectives. The eye line and the horizon line rises up to the level of our eyes. If we're 40 inches off the ground, that horizon line lines up to the level of our eyes. If our eyeballs are 5 feet off the ground, the horizon line rises up to the level of our eyes. If we are 9 feet off the ground, again, the horizon line rises to the level of our eyes. And if you've ever been to a beach or something like that. It's very easy to see the horizon. You just look out into the water and you'll see, in the distance where the land, or pardon me, where the water and the sky meet. And if you lay down in the beach with your chin in the sand looking straight out, so your eyes are like 5 inches off the ground, the horizon line would be 5 inches off the ground. It would meet where your eyes are. If you, climbed a ladder, 15 feet up this ladder, that horizon line would rise up to be 15 feet, from the ground. If I was in a 30-story building, that horizon line would rise up 30 stories and it would be level with our eyes. So the horizon line and the eye level is basically, if this is our ground, it's how far your eyeballs are off the ground. That is what the eye level is. And so we need to keep that in mind, because whenever we are, have our eyes open, we have a horizon line, and that's what this is right here, is our horizon line. And whenever we draw, we want only one horizon line. Just like we want only one line of sight, we need to have only one horizon line. If I tried to draw something where I had some still life that was seen while I was sitting, and then I drew on the same plane the view I had when I was standing and the view I had when I was standing on a ladder, it would look very bizarre and it would look mixed up and it wouldn't make sense. We need a consistent eye level, we need a consistent horizon line, and there is one always present. Whether we use it or not, it's there. Perspective is always in affecting the world around us, because perspective is no more than how we see. Perspective is about the way our eyes perceive three-dimensional space and dimension. Now, something we also want to remember with the horizon line is that on our horizon line, this line represents a vertical line that passes through the middle of our eye. Okay? And so, if you could imagine a midline passing through the middle of your eye, and it does, we have to imagine it. Obviously, it's not tattooed on there, but the line going through the middle of the eye would be the horizon line. Okay? And so again, the eye line and the horizon line, as long as we are on 1-point perspective or 2-point perspective, the horizon line and the eye level are the same thing. And there's also a vertical line that represents the vertical line that, again, is this vertical line on the back of our cornea. So we have the horizon line is the horizontal line, and the center of vision is a vertical line, and so we get a crosshair. And again, that crosshair is very important. And we've talked about the line of sight. From that crosshair, the line coming out from there would be, now I'm not standing this straight up so you can actually see the pencil coming off. If I stand it straight up, you probably can't see it as well. But the idea is, from this point where the horizon line and the center of vision cross, if I come straight out from there, that's the line of sight that comes out from our eye as far as we can see. So perspective is really no more than the way we perceive the space. It's about the way the eye is constructed. It's all kinds of good stuff. But the center of vision and that horizon line, again, horizon line is the horizontal line going through our eye, and the center of vision is the vertical, as if we were looking through some binoculars or something with a crosshair. So we're going to keep that in mind as well, because that becomes very important as we draw and paint. So, and I've got indicated the center of vision right here, but let's go. So this shows the horizon line here and the center of vision right here. Okay. But the next thing we want to understand is that when we have boxes, and when we're drawing boxes, that as we have parallel lines that recede away from us into space, that those lines will meet at a vanishing point. So if you've ever looked down a highway, a long stretch of highway, and looked down that highway, you can see the highway, if you can see for like 10, 20 miles, you'll see the highway getting smaller and smaller and smaller and smaller and smaller until it appears to disappear in the distance at a point. And that point is on the horizon line. And what that's called is a vanishing point. Same thing would happen if you've been able to see a long set of tracks and walk down, train tracks. You would again have these parallel lines would appear to vanish far off into the distance. So with the horizon line, we have lines that are going away from us will go away and deep into space, and they meet at what we call a vanishing point. These are vanishing points here, vanishing point there, a vanishing point. So again, that's where parallel lines will meet. Okay. And in this class, we are going to discuss 3 different types of perspective, but we're going to start with the first 2 that are the most common. So we talked about our front view cubes versus our corner view cubes. And in this class, a front view cube is going to be referred to as a 1-point perspective box. So no longer is it a front view box, but it's a 1-point perspective box. And then the corner view boxes are going to be referred to as 2-point perspective boxes. Okay? And so whenever we are dealing with 1 or 2 point and we have a horizon line, if it's 1-point perspective, there's only one vanishing point. That's why it's called 1-point perspective. Those lines go away from us and they converge at 1 point on the horizon line, and that is what we refer to as a 1-point perspective box. Now, if I have a corner view box where I have a line coming to the left and a line coming to the right, well, then we have 2 vanishing points, well, then we would call that a 2-point perspective box. So 1 and 2-point perspective. We also, in the lesson, are going to cover 3-point perspective, but for now, let's try to understand 1 and 2-point, and then once we understand that, we will add the ideas of the 3-point perspective. But with 1-point perspective, you have one set of lines that go to a vanishing point. With 2-point perspective, you have 2 sets of parallel lines that go and disappear at a vanishing point. Now, the vanishing points, they represent this large distance. And people will say, well, they represent infinity, and that's correct. But when anyone ever uses the word infinity, my brain starts to spasm a little bit. I mean, I know what infinity means, but I do better with an actual depth. So usually I like some people say it's a distant star. I like that one better. Or it's 30 miles away and it disappears on the on the horizon line. That's fine too. That measurement gives my brain oh, okay, yeah, I can conceive of that. My brain has a harder time conceiving of infinite space that never ends. So anyways, but that's what they represent, this far distant point at which the lines will converge on the horizon line. Okay, and again, vanishing points are only on the horizon line for 1 and 2-point perspective. Only on the horizon line. We'll never have vanishing points off that horizon line until you get to other types of perspective, 3-point, 4-point, 5-point, that sort of thing. But we're going to keep it very simple in this class. The other thing we want to understand, again, we have right here that all parallel lines that recede into space, as we talked about, meet at a vanishing point. That's important to understand. And we've already talked about that, but this is showing these red lines coming and meeting at this vanishing point right here on the horizon line. So the relationship of these red lines is that every one of these red lines is parallel one to another. All right? Any lines that meet at a vanishing point are parallel one to another. That's important to understand. Okay? And and we have the blue lines over here. These are also parallel, and they meet at a vanishing point over here on the horizon line. So all these blue lines are parallel. But here's the thing we need to remember, is that where the red and blue line cross, where that red and blue line crosses, they cross at an angle. The red lines and the blue lines are not parallel one to another. They meet at an angle, and the angle is 90 degrees. So perspective is all about cubes. It's all about what we call cuboid space. And if you take a cube at any corner, that cube is 90 degrees. Now, it's 90 degrees in perspective. It's not an actual 90. So I could have these two lines. This line here goes to that vanishing point. That's parallel to the other lines. This line here is parallel to the blue lines. These two, you'd say, well, this could be a red line and a blue line meeting, but there's no angle whatsoever. And yet, if there was a corner, that would still be 90 degrees. As these angles get closer to the horizon line, they splay open. And as they get further down or further up, they get more, they close down. So they open up and they close down. As it gets closer to the horizon line, they open up even more. So and if they touch the horizon line, the angle becomes a straight line. You can't tell. We'll talk more about that later. But it's important to understand that all lines that share a vanishing point are parallel. Therefore, the blue are all parallel, the red are all parallel, but where they meet at 90 degrees. Okay. Now, the last thing we want to understand about perspective is that perspective gives us two things. And again, perspective is always happening. Whenever we're looking at something with our eyes open, there is perspective in play. And so we want to keep that in mind too, because we want to draw good. That's why we're taking this class, right? We want to learn about this stuff. So the two things that perspective gives us is, one is diminishment, and that means that things of equal distance get smaller as they go back. The other thing that it gives us is foreshortening, which means that things of equal length get smaller as they go back. So let's talk about diminishment first. So this right here, if this is a plane, these two lines go back and they meet on the horizon line at the vanishing point, and they meet at a vanishing point, so they're parallel. This is parallel, that's parallel, that's parallel, that's parallel. Parallel doesn't care about vertical or horizontal, vertical or horizontal. It just doesn't. But if this right here is a 30-foot line of a 30-foot plane, this back here is shorter, but it's still 30 feet because it's 30 feet that's further away, so that 30 feet gets smaller. And then again, this would be 30 feet, and this would be 30 feet, and this would be 30 feet, and that would be 30 feet. And if we put a line all the way back here on that plane that's so small, it's still 30 feet that gets further and further and further and further and further away each time. So it's not that the line is getting shorter, it's just because of perspective, because of the illusion of things diminishing, the same distance diminishes and gets smaller. Same thing here, 15 feet. This is 15 feet, that's 15 feet, 15, 15, 15, 15. That 15-foot line gets smaller as it goes back. Same thing here. If this was 45 feet, 45, 45, 45, 45, 45. And again, all the way back to these little lines, all the way back there. If I connected the top and bottom of this line all the way back there, that line is 45 feet. It's just way, way, way far away from me, and that's why it's so small. The other thing it gives us is foreshortening, and foreshortening is equal distances get smaller as they go back. So if this is like two telephone poles and they're 100 feet apart, well, here, these two telephone poles, these are supposed to be equal distances. This is 100 feet, and this is 100 feet, and this will continue to shrink and get smaller because of foreshortening as it goes back into space. Now, an easy way of thinking of foreshortening as well is that if I hold this pencil flat on this piece of paper in my hand, you can see the full length of it. But if I begin to rotate this towards the camera, this is going to start to get smaller. It seems to get shorter and shorter and shorter until if I hold it straight up, you can't hardly see any of the length at all. It seems very, very, almost a circle. So foreshortening is always happening around us, and we need to be more aware of it. So these are the concepts that we need to understand. Diminishment, foreshortening, parallel lines meet at vanishing points, that we have either a 1 point perspective. If it meets at only 1 point on the horizon line, that's 1 point perspective. If they meet at 2 points, that's 2 point perspective. And so these are the fundamentals that we're going to work with throughout this class. Diminishment, foreshortening, parallel lines. And never forget that whenever you're drawing a box, it's always has to echo this rule. You could almost call it a law. But this rule that it's a 3D image, and so it has 3 sets of lines. Height lines, and depth lines, and width lines. Within each set, there's 3 or 4 lines, and the relationship of those lines is that they are parallel. All right, so let's go ahead and get started by delving into 1 and 2 point perspective using these concepts. We're going to walk you through it, and we're going to have lots of good fun, so let's get started.